Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, I'm going to talk about GNV6 internal equipments.
This presentation divides into these four parts. We also take a video of GMV6 outdoor unit internal equipments, which can help you to recognize them. If you are interested, you can scan this QR code or go to the linkage to watch this video. Next chapter, we will go to the valves.
Four-way valve. Here is the appearance of this four-way valve. Actually, for the this one for GMV system, it is similar as the residential air conditioner. And also, here is the sectional view. So you can find that this one connect to the compressor discharge, we call it D port. And this one connect to the compressor suction side, we call it S port. And here connected to the indoor unit for cooling, evaporate, we call it E port. And this connect to the outdoor condenser for cooling, is for C port. Also inside here is a slider. When we change this direction, also we conduct the cooling and heating to change direction. But it is not controlled directly by this slider. It is with a pilot valve, which is this one. Actually, this one is a small size four-way valve. You can find that there are small size capillary, and you will detect the value, the pressure value, and then conduct the slider to move. Later, I will make a detail to explain. And anyway, this solenoid valve is the key components located here. This animation displays how this four-way valve moves. And on this case, currently this four-way valve is for heating because the gas from the compressor discharge, it is hot and first flow to the condenser, which is to the indoor unit. And also you can find that here is the refrigerant from the evaporator. It is low pressure. And from here we go to the compressor suction side. And also this one detected the pressure to just connect to this solenoid valve. And also connected the pressure from the discharge, and this connected to the compressor suction side. And when you would like to change to cooling, we just make this solenoid valve to be operate just like this. When you get the power, then it will change the direction to make the inside pressure to push this slider to move to the other direction, which to conduct the refrigerant to change the direction to the other side. Then we change to be cooling. And also you can find that this S pi is always the low pressure, and this D pi is always the high pressure. And on side, for the malfunction case, you will always find that the gas missing. The gas missing means that this slide just crack in this middle position. In this case, this gas from the D pipe can flow into these three pipes. That means it cannot make cooling or heating. And here is the reasons why we need to or for this gas missing. First is the not enough power for this solenoid valve. So you need to check whether you can get enough voltage from the PCB to push this slide. And then the next is smooth movement of the slider, which means inside this one, it should move smoothly. And the impurities on or the debris from the installation will maybe we get inside and also make it to be cracked or not make it to move smoothly. And for example, if this cylinder it is deformation, also make this slider cannot move. And the last is the cleanness of this four-way valve, as this is the capillary tube, and it is a small size, which means it will easily to make it to be blockage. And also on side here is the checking method to confirm this gas missing. You can touch this E and C pipe. If the temperature difference is huge, that means it is okay. And on the other hand, you can also check the suction temperature. This one, if you find that the temperature is higher than the environment outdoor ambient temperature, so your judgment is yes, you can also confirm the gas missing. On the other hand, you can also check this value from the portable debugger or from the commissioning software on the PC. One-way valve or check valve located here between the four-way valve and the oil separator. And here is the appearance and the sectional view. Inside components is including these three. The function of it is first to lower the startup pressure difference. For this one, we can prevent the refrigerant to flow back from upper side back to the compressor to help the compressor to start up easily. The next is in heating mode, as this one just connected to the gas pipe, which is here. This can prevent the outside refrigerant to flow back or flow into the compressor from other outdoor units in a modular system, just like this, to prevent the refrigerant. It will be stopped here. And the installation requirement for this one is upright and also follow the indicated direction. This direction. EXV, short for electrical expansion valve. In this diagram, you will find that for the single compressor system, we have 3 EXV, which is the heating EXV, subcooler EXV, and also the EVI EXV. This is the EXV sectional view. You can find that here is the coils, and this is the inside pin. We're just making the coils, which is to input the pulse to making the inside pin to moving up and down, and the refrigerant will just get through this port and also get expanded here. You will find that this area is very narrow, and the water and also during the installation, the impurities and the debris will easily to get jammed here, and that's also the reason why we require to clean all of the impurities and also no water. Also, you can find that here, which is this one. There are the thread. This is for the dedicated control. For the PCB, you can find that here is the terminals just for this EXV. And for the heating EXV of the GMA6, there are 6 cores, which is this one. This slide is the comparison between the GMA5 and GMA6. So you can find that for GMA5, it is this one, and GMA6 is this one. First is just from the size, you will find that this is actually much bigger, and that is also the reason we can cancel this check valve. You can find that on the GMA5 we have this check valve. The purpose of it is just to make the refrigerant, especially in cooling, to get through this part as soon as possible. Do you know why? The reason it is that in cooling mode, which is the refrigerant will flow from the outdoor heat exchanger, and actually at this part is already the liquid. And in system high frequency, which is the compressor in high frequency, the refrigerant flow rate will be very high. At that time, even this EXV is fully open, but it is not enough, which means the refrigerant will get expanded here, which is not we want. And then we create this bypass and make the refrigerant to flow through at this part as soon as possible. But for GMV6, as the size it become larger, and we can cancel this bypass. And just due to this reason, we can make the system components not that many, and also leads to higher reliability. On the other hand, as the control is up to 3000 pulse, we can make the control to be more dedicated. Next is solenoid valve. In the single compressor system, which is this one, we have 4, which is the subcooler valve, gas bypass valve, assistant oil return valve, and major oil return valve. And the purpose of this one is just to control the refrigerant to go through or not. And here is how it works. And also on side, you will find this the indicated direction to install this solenoid valve. And basically, the refrigerant only flow from A to B. And the working theory is also very simple. There is this coil. When it is it can get the power, then it can make the inside pin to be going up, and then the refrigerant A can flow to B.
Filter. Inside the GMV outdoor unit system, you can find that there are lots of the filters inside it. Actually, in our grid design system, when the refrigerant will go through the narrow passes, including the EXV, solenoid valve, and also when the refrigerant go in or go out the unit, we always will put a filter to block or to stop the impurities or debris from getting into the narrow passes. And on side, you will find maybe this structure, and this is the another structure. This is the sectional view. Inside it, there is a filter neck to hold the impurities or debris. Unloading valve. On this system diagram, you may find these two, 1, 2. And the purpose of this one is just to release the high pressure to low pressure side to protect the fragile components like the EXV, which may be very sensitive to the high pressure. And here is how it works. There is a spring here. When we detected the pressure is higher than our setting value, it will conduct these two pipes conducted, which will conduct the high pressure to the low pressure side. And here is an example that during the storage from the liquid valve to the 2 EXV, which is this one and this one to this one, there are full of the liquid refrigerant, right? And during the storage or the transportation, maybe the warehouse or the outdoor ambient temperature, it will be very high. At that time, it will heating up the inside liquid refrigerant to make it to be very high temperature. And as you know that higher temperature also means higher pressure. And sometimes maybe the temperature will go as high as 70 degrees. At that time, the pressure is our preset value, which is to protect the EXV. The maximum for the R14A is only 4.3 or 4.6 megapascal. So we need to release the pressure. And then you can find there is an unloading valve here. You just connect this one. and to this part, this is connected to the gas liquid separator. It is a low pressure side because it has the large volume. And then we will turn it on to conduct the high pressure to here to release the pressure to protect these two EXVs. And also when on site, you install requirement is upright. Valves, which is the cut-off valves, and for GME6 we cancel the oil balance valve and also make the oil charging valve to be an oil charging port. And this is the appearance of this cut-off valve. Here is the gas valve, liquid valve, and also the low pressure check valve. And as for the oil checking valve, we make it to be an oil check port, which is located here, just like this one. That's all for this part of the presentation. If you still have any other question, just feel free to contact me on my personal email address.